Hello guys, welcome yet again. Um, Last week I was watching this video from Zodin, Mr. Zodin, about the D language, and I remember it made me remember how I really like the language. I like the array features that's already implemented in the language. Different from C++, it's already implemented in the languages, so you don't have to import a library for that. I like the way the structure works, the structures and the classes. There are some things I don't like about the language, but I believe it's a really good language. It should be used more in embedded systems, and that's what I'm trying to do in this video. I'm going to do a simple blink LED in the D language. In fact, this is not the first time that I record this video. Yesterday I recorded it, but I showed all the processes that I was reading, the websites and stuff on how to do that. So it was a really long video. So in this video I'll try to be brief and straight to the point, if I remember everything. So let's go here. I'm going to use the STM32 F4. It's this board. I have already used it in another video for the assembly. So what I already have here, I configured the cube ID so that I have a pin A6 as output. I also enabled serial wire debug and set the clock configuration to max, so 168 megahertz. I'm going to close this for now. I believe we won't use it anymore. So let me take this here and show the code. So what we have here is the code generated by the cube ID, and what it ends in the while loop. It only toggles a pin, but what do I want to do? I want to, before the while loop, I want here to jump to the D code. So let's try to do that. Let's first create in core. Let's create a new folder called D source. And then inside this, I'm going to create a new file called main.d. Okay. It open case, but I'm not going to use the case editor. Okay, and we need something to build everything. So let's go here to debug, and here we're going to create another file. This we'll call build d.s8. Okay, it's also open case, but I'm going to use I think Neovim. Okay, let's open a terminal here. IDE, let's go to my workspace. I have the project here, dtest. Okay. Then I'm going to open my build site. Okay, so user in bash. Okay, exit at the end. Let's do this. Let's do the following. First, we need a folder to put our output file. So let's create a make dir /p if it already exists. Let's call it. We want to replicate these, so let's call it dot the source. Okay, I believe that's it. And then we're going to do the compilation command. And how do we do that? Here we have some examples, one from 2013, another from 2017, I believe, how to use that. And then they have here the commands to compile. One uses LDC and another GDC. But to use GDC, we probably have to compile the source code, so I don't want to do that. And we have here another example for the Cortex M3. Okay, what is the command? It's the same. Let's use LDC. Okay, so let's do LDC2 dash, what's the name? march equals thumb, and m CPU equal to Cortex. But since this board is a Cortex M4, we're going to use M4 here. Okay, one more. Dash C for compile only, so we're not going to link for now. Then dash G for debug symbols, and then the name of our file, and it is main.d, but we have to go into the source code directory, so we're going to go one folder up, and then core the source. Okay, so let's do that. Dot core. Okay, the source main.d. Okay, and let's use the dash better C. Is that it? No, it's only one dash. Okay. You can see these options if you open here LDC2 dash help. You can, for example, and then if you use that LDC2 dash help, you're going to see a lot of things. If you want to look for something, you can use grep, and then like use the keyword you want, beta C. So when you use dash beta C, okay, pages dash. Omit generating some runtime information and helper functions. Okay, let's use that. And how do we call this build script in the STM cube ID? So let's right click in our project. So let's go to properties, C++ build. Let's open this. Let's go to build variables, environment, settings. Okay, build step, and that's it. We open the properties, C++ build, settings, build steps. So you have here pre-built commands. We can put here the following: bash. Okay, bash build d.sh. Apply and close. Let's see if it runs. It won't run. So when we try to compile this, what happened is the following. It ran our script. Okay, and what happened? Did it generate our code? No, I believe there was no problem because our source code is empty. So let's close this and let's open now for resource main.d, and then let's do void main. Here's where everything will happen. Let's do like while true, let's try to compile again. Now, this is the problem. We couldn't find an entry point.d. Only error. Only one main allowed. Previous found main at. Okay, so we cannot use main. Is that it? So let's call d main. Let's see if it helps anything. Let's clean and clean project. Okay, it seems to have worked. So okay, let's try to call it here. So we have the main. We have a warning for implicit declaration of the main. Okay, let's go up here to the main.c. Private function prototype, let's call extern void the main. Can you try to compile again? Now we have some other errors. Undefined reference dmain. It couldn't find dmain. So let's do the following. It's because of name mangle. So we can use extern c. Let's try now. Okay. Now it's not because of name mangle. So let me delete this. It's because I didn't try to link with my code. So let's go to the properties. Now we have to link with that code, with that generated code. So guys, let's go to properties, C++ build settings, tool settings, and then MCU MPU GC linker. Let's see here, general, libraries, and miscellaneous. So we have to include here the additional objective files. So let's include that. We're going to use this command later. That's the no z stack, but that's later. So let's do the following. So we go to workspace, go to our project, the test, debug, drivers. Sorry, it's not drivers, it's core. It should be here. Okay, I know now. Because our D source, it should be inside core, not. So let's add it to the bug and then build. Let's see. We have to set the output file. Here is core. And then this source, it will create inside the debug folder, and then we have to set the output file. How do I set the output in LDC? Output, let me see, OF dash OF, okay, dash OF equal to dash core the source and then the name of the file, so main.o. Okay. So we can delete this folder here. Okay, and let's see what will happen. So it's okay, there's a T source now inside the debug core and this source. And then the main.o is here, and I can also include this other main.o. So let's see what happened now. So we still have to link. So let's go back there. Miscellaneous, additional object files, workspace, dtest, debug, core, dsource, and main. Okay, that's it. Okay, rebuild index, apply and close, and then let's try to compile. And then a lot of errors now. Lots and lots of errors. Undefined reference to the main. Now I believe it's the name mainly, so let's do external C. And let us see. Okay, external C, no identifier for that. Like, there is no external C. So I know what works is pragma mango dmin. Then let's try to compile. So there is no. Oh, I'm still confusing everything. Let's try to compile. Then still an undefined reference to dmin. Okay. So let's open this. There's a module start. Okay, let's call this like module main. Okay, it's not that. Okay, so we have it's that. So we have to declare here a module in the main.d. So I called here in the first line module main semicolon. So you have to do this and use pragma so that pragma mango dmin, so that this function here can be called, can be recognized from the C code. So, but we have now another error. When you look here, is the following error: dtest elf uses VFP register arguments. So this has to do with floating point values, but it is using soft values. So we have to use in our compilation command, we have to use something for the floating point. So let's try to find it here. So ldc2 -- help wrap floats. Let's do. So we have here -- float ABI equal value, and I know that this can be default, soft FP or hard. So let's use hard, because when you look at our project configuration, MPU settings, let me see here, MCU settings. So we have here floating points in hardware implementation. It is using the hardware implementation, and if your microcontroller doesn't have a hardware floating point unit, you should use soft in the compilation. So let's do that. So it's -- float ABI equal hard. So that's it here. -- float ABI equal hard. Let's try to solve that again. So we have another error, and then this behavior is deprecated. Okay, this is that part where are the... I said that we're going to use those that argument for the link. So let's go back to the project properties, miscellaneous other flags. Let's include another flag. So the flag is -z space no easy stack. Is that it? I don't remember. Probably it's not it. So let me try again to compile. It's not it. Let me try to find. Node. So let me try to look for that. I searched for it yesterday. Here. No exec stack. Okay, so let's open the properties. Not here. Here. Properties. Miscellaneous, no exec stack. So it should work now. Rebuild index, apply and close. So that's it. It compiled and it is in the domain. Okay, let me try to... You can see here that there is a blink LED in the while loop after the domain, and I already tested this code. It's already blinking, but it shouldn't blink when we run the domain. So let's do that. So as you can see, the LED is blinking, but it is from the previous code. So let's try to run this code now. It should stop blinking. Let I see. Yeah, it stopped. So that's it for now. But let's try now to run the blink from the daemon. So let's do that. So let's go to our daemon. It's open here. Now the problem is, how do we import the functions or structs from the C code? That I still don't know. I know how to do the following. Let me open the GitHub page and go to my page. So I'm going to need to use this, maybe this and this. So maybe for now I'm going to use the registers. Then later I'll try to learn how to import the how functions. But right now let's do the following. Let's declare this. So how do we declare this in D? We can do a enum GPIOA base is equal to 0x40020000. Is that right? Yep, that's right. And then we need the GPIOA BSRR. Enum GPIOA BSRR. Okay, and then it is GPIO base plus 0x18. Is that it? So that's it, 0x18. So this is already configured for us from the HAL library, from the STM32 cube IDE. We only have to do the blink. So let's do this. Let's open them side by side so that I don't do anything wrong. So we have to set BSRR pin 6. Okay, let's do the following. Maybe we have to create a pointer. Okay, okay, pins. Yes, okay, let us see. GPIO ABSR. Let us see if this will work. Probably not. So it doesn't work, cannot implicit convert int to int pointer. So let's do the following. It does a cast int pointer. Let's see if it compiles. Okay, undefined reference to the main. What happens now? The main and external void the main. It couldn't compile. What happened? So it compiled, so something was wrong. Okay, it compiled. So now we can set BS pointer pin 6, bit 6, and then we have to set the 6 plus 16. Choose. Okay, let's do this. SPS 1 6 plus 16. Let us see if it compiles. It compiles, everything is great. But how do we do the delay? How can we make a delay function? We could create a counter, but we already have a delay function. We have HAL delay. And it doesn't use anything from the structure or anything, so maybe we can use that. Let's try to do that. So let's call it here HAL delay 500 and also HAL delay, let's do 100 so that we can see the difference. And let's try to compile this. An identifier. Okay, so maybe we can say that it's an external function. External C HAL delay. It receives uint, and that's it. Let's see if it works. HAL delay uint. No identifier for declarator. External C. What is wrong with my external C? I'm probably writing something wrong. So let's open the lang.org documentation language reference functions. Okay, let's see if there's an external. Extern, maybe it's extern. That was the problem. So okay, it shouldn't return type. Yes, it's missing the return type now. How could I forget that? So, okay. So maybe here, let's try again use removing the pragma. So here we can do like an extern C also. So we have these two options. I wrote it wrong. So we can use extern C or pragma mingle D main. When we use extern C, it means that it won't mingle the name because the C functions doesn't use name mingling. So let us see if this works. I will connect my board here. Okay, my board is connected, so I try to run this code. So I hit play. Let us see if it works. And it works. So let us see the debug file. The assembly file generated by the domain. Let's look for domain. Okay, next domain again. Okay, there are some restrictions, some extra structures here, but it works. What if we increase the debugger, the optimization, for example? It's 03, 02 for 01. Let's use 01. Okay, and compile again. Let's see if anything is different. Domain. So here is domain. So it's a lot different here. Huh? What is happening? I have no idea. So it stores the value in R0. Okay, I get it. There are already some values set here. So let us see if it works normally. So it keeps working. So let's try to debug this. So, okay, I don't care about this. Let's create a breakpoint here in domain and run. And run again. So it hits domain. So we're going to step into. Oh, I hate this. Every time I go to domain, it opens the source code, but we can do here, we can see the assembly. Okay, then we can step into the, let's for example create some breakpoints here, another here. Here. How delay. Okay, let's run. Hit run. I don't know why it keeps opening it. If anyone knows how to stop it, please tell me. So it turned off the LED. Turned on. Turned off. Turned on. Okay, so it is working. I only don't know why it keeps opening the Vim editor. I don't want to open any editor, so but that's it, guys. It seems to have worked. You can see the code is blinking. Let's try to change the values like 200 and 200, for example. And let's compile and run the code. To see if it will change the blink pattern. Yeah, it changed the blink pattern, so everything is great. So I'll try to learn, not in this video, but I'll try to learn how to import the structs. So if we can import the structs defined by the how, we could maybe use those structs in the decode, and maybe if we can use the structs, we'll be able to use the functions, all the functions, because here we could use the how delay function because it didn't take any struct, only a number as input, an integer. But I really like the language. The array features. There are safety we can turn on, and a lot of things I believe are good for programming. We could use also for all the constructors and destructors that aren't available in the C language. And those things are a lot better in the D language than in C++, so it's a really good alternative. Maybe I'll try to, when I learn how to use those structs, I'll try to bring in something new here. But that's it. I'm sorry I didn't aggregate much in our life, but I believe these are really good language. We should give it a try. So, but that's it. Until next time, guys.